Hello, this is Mr. Spy, and this will be the second part of my video on graphing piecewise linear functions. Let's continue where we left off with the first part. First, let's go over how to read a piecewise function. So the first thing you look for are the restrictions. So you look where each part of the equation starts and ends. So the first part starts at -2 and ends at +2. And since both are closed points, they're less than or equal to. The second part starts at 2, ends at 6. And since the first piece is open, we use a strictly less than sign. Then we need to find the slopes and y-intercepts of each. So let's first find the y-intercept of the one that's easy to find, which is the first rule. The y-intercept is there at 6. The slope is down 3, right 2. So that'll be -3 half x plus 6. Now, the second rule is a bit harder to write. You first need to find the slope, which in this case is up to right 1, which is 2x. But the y-intercept is not there, so you use the slope backwards until you get the y-axis. So instead of going up to right 1, we're going to go left 1, down 2. Left 1, down 2, where we hit at -3. Because you want to see where that line would hit the y-axis if it was continued on. So it's -3 halves x plus 6 and 2x minus 3. Not easy to do to write these equations, but let's do another example. In this case, we have a special function called the step function. It's where every piece is a horizontal line, every piece. And you do the same thing. You first look for the restrictions. So our lowest value is -1, -2, -3, -4, -5. We don't want to include that. And we go until -2. At -2, we're not including that. And we go until 3. And the next piece is 3. All the way until 6. And then you just write the numbers because it's a step function. So the first piece is at +2. The next piece is at -3. And the last piece is at +4. This is at 2, this is at -3, and this is at 4. That's a step function. It's a very unique function where it's certain values at one part, certain values at another part, and it works like a staircase. Now let's do the reverse. Starting with the equation, how do we make the graph? So we want to learn how to graph this function. The first thing you do is you draw your axes. There's your x and y axis. And the first point you plot is the point where it changes functions. So in this case, it's 0. So you do f of 0 in both equations. Get 11. And that will be a closed circle. In the other equation, you plug in 0. Get 8. That will be an open circle. So let's plot the first point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a closed point all the way up there. And then at 8, you have an open point right there. Okay? Then you just plot the points. So you start at -6. 3 times -6. Plus 11, which would be -9 sorry, negative 18 plus 11, which is negative 7. So it'll be another point here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So right here. Yep. So there will be my starting point. And we're using a slope of 3 to connect this point, oops, to that point. So a slope of 3. And then we'll do the same thing with a slope of a half, starting at the other point. So up 1, right 2, up 1, right 2. And we'll extend this line until we reach to 10, which would be half of 10, which is 5. 5 plus 8 is 13. So the last point will be over here at 13. And there won't be an arrow. We'll just connect them. And we'll include 13 with a closed circle. And these are really complicated to draw. I highly advise to always check your graphs if you can using Desmos. And I'll go over how to do that in a different video, but they're not easy to graph, these functions. And you have to be very careful to make sure you fit everything. I didn't even fit everything I wanted to on the graph. Okay? Now it's much easier to draw a step function. Same as that idea. Draw your axes. Y, X, put arrows at the end. And then you look, okay, we're starting at 0 and we're going to 3. And we're going at a height of 2. Let's change colors. And let's look at this. So at a height of 2, we have a closed circle at 0. So let's draw back our So Y, X, sorry about that. Must have hit something that went to that screen. And then you look at it, okay. At 2, height of 2, you have a closed circle. And at 3, you have an open circle. And then you connect those 2 points. Then at 5, you go up to 5. So a closed circle here. And then you go to 5 over here. So open and closed. And then at negative 4, you're all the way down here at negative 4. 1, 2, 3, 4. And that will be a closed circle. And then you go to 10, also closed. Connect those 2 points. And you get your graph. I apologize, it's not the greatest graph, but that's the basic idea. This is at height of 2. This is the height of 5. This is the height of 4. And this is 10. This is 5. This is 3. And that's 0. Okay, really hard to draw, but takes practice. Let's continue. Okay, now there's some special step functions. There's the round function, the scaling function, and the floor function. So when you're rounding numbers, which is usually where step functions come in, it matters how you round. Round does exactly what you think. If I was rounding the number 3.1, it would be 3. If I was rounding number 3.7, you would round it up to 4. But ceiling and floor are unique functions that always round up or always round down. Ceiling always rounds up. So if I would look for the ceiling, 3 is like a bracket with only tops. Of ceiling, let's say 3.1, that will be 4. Ceiling of 3.1 always rounds up. 3.1 will become 4. If I use a floor function, it always rounds down. And those are brackets with just a floor under it. And if I would do the floor of 3.7, that would be 3. So ceiling function always rounds up. Floor function always rounds down. And the round function does exactly what you were taught when you were taught how to round. And all these graphs are always step functions. It makes every decimal into a whole number. Doesn't matter what the fraction part is, it rounds it up or it rounds it down. Scaling function always runs up, lower function always runs down, and the round function, notice it has both a top and a bottom, so it rounds to where it wants to, or what you were taught. Below 0.5, round down, 0.5 and above, round up. Now sometimes we are given a non-linear function. Well, the second part's linear, the first part is quadratic. And I'm doing this to introduce the next unit. So when you graph it, you do the same thing. You draw your x-axis, you draw your y-axis. You plug in the point where it switches. In this case, that's 0. So that'll be 0 squared plus 3, which is 0. And then wait a minute. If you plug 0 into the second function, 2 times 0 plus 3 equals 3. So both cases, they both equal 3. That means they share the point where they meet. So that'll be right here. At 3, they share this point I'm making in black. They share this point. And then you draw your line. Well, for the second piece, you're going up to right 1. Up to right 1. So you're going to get this line on forever, and this is my 2x plus 3 piece. Now the other side is a parabola, and that makes a curved U. So it looks like this. And that's my x squared plus 3 piece. It's a sketch. I'm not drawing it perfectly, but it'll be like a U that switches to a line. And that'll be my graph, f of x. And that's how you graph them. You plug the point in where it switches equation. It's the most important one. You must plug that one into both. And then you figure out what the other equations do. In this case, you look at the slope for the line, and you plot points for the x cubed plus 3, which makes a parabolic shape, which is a letter U. Hope this was helpful. This was a 2-part video on graphing piecewise functions. This is the last video in Unit 2. I know I have not posted any of the videos in Unit 2. I'm going to work backwards, starting with this penultimate video. There is one other lesson I'm going to be including in Unit 2 about graphing using Desmos and a graphing calculator to help you with these questions. And I hope this has been helpful for you. If there's any other topics I can make many videos on from Unit 1 or Unit 2, or anything from Algebra 1, Geometry, Algebra 2, please subscribe to my channel, hit the bell for notifications. This is and post in the comments what do you think of these videos. This is Mr. Spy. Hoping this was helpful for you, and signing off. Have a great day.